Hi everyone, welcome to this session. So, am I audible to all?
Yes, you're audible.
Okay. So, the in the era where we have a number of programming languages, frameworks, libraries to work on, it's pretty hard to choose amongst those. Means which library to work on, which modules, which frameworks. But what I can see is the problem remains same. Means when it comes to the development, still we are facing some efficiency, resilient, and concurrent issues. But what if I say yes, we have something which brings all together into a single module? Means we have something which you can use while you do programming, while to make your program, your application much efficient, concurrent, and resilient. So in this session, one of my colleague, Pallav Gupta, he will help you in figuring out the problem and how to work with that particular thing, which the Pallav is gonna elaborate in a very short. Will help you to develop such an application which is perfect in all manners. So I welcome Pallav Gupta. Please,
Hello,
Pallav,
everyone.
announce yes.
Yeah, I'm sharing my screen. Let me know when it's visible.
Yes, it's visible, Pallav.
All right. So let's move forward with the session. So, hello, everyone. Good evening. My name is Pallav Gupta, and I'm working as a software consultant in Nordis. Today, I'm going to deliver a session on introduction to ZIO, its data types, and exception handling. So, before moving forward in the session, let's take a look at knowledge etiquettes that are punctuality. We must all join the session 5 minutes prior to the session start time, as when we start on time, we conclude on time. Silent mode. We must keep our mobile devices in silent mode and feel free to move out of session in case you need to attend any urgent calls. Feedback. Make sure to submit constructive feedback for all sessions as it is very helpful for the presenter. Avoid disturbance. Please keep yourself on mute and try to avoid any kind of unwanted chit chat during the session. Now let's move on and take a look at the agenda of today's session. So our agenda will look like we'll discuss about the introduction of ZIO, then we'll see few the features of ZIO, its data type, and how we can handle exceptions along with its demo. So moving forward, so before moving, I would like to ask that anyone in this session knows about what is ZIO, what does it mean, how it is helpful. Anyone like to share? All right. So let me just move forward and start with the introduction. So the ZIO, the Z in ZIO came from the Scala Z, and the IO came from IO monads. So ZIO is a concurrent programming library which uses Scala programming language capabilities to help us design efficient, resilient, and concurrent applications that are simple to understand, test, and do not leak resources, cause deadlock, or cause errors. ZIO frees up the developer to focus on business logic and fully embrace the features of Scala programming language to improve productivity, testability, and resilience. ZIO is a next generation framework for building cloud native application on the JVM with a beginner friendly yet powerful functional code. ZIO is built around a powerful data type called ZIO, which serves as the foundation of any ZIO application. ZIO is a library which works on purely functional and showcase the power of pure functional programming to solve modern business problems. Now, when we are talking about purely functions. So what is pure function? So pure function are the normal functions with some characteristics, like it should be total, it should be it should not be partial. For every single input, it have a output. There should be no randomness. There should be no side effects, no null values, no exceptions would be there, and then there should be no mutations. Instead of var, we use var for immutability. So, moving forward, features of ZIO. So, concurrency. Using an asynchronous fiber-based model of concurrency that never blocks thread or deadlock. ZIO can run thousands or millions of virtual threads concurrently. Efficiency. ZIO automatically cancels running computation when the result of the computation are no longer necessary, providing global application efficiency for free. Error handling. ZIO lets you track error statically, so the compiler can tell you which code has handled its error and which code can fail, including how it can fail. Resource safety. ZIO automatically manages the lifetime of resource, safely acquiring them and releasing them even in the presence of concurrency and unexpected errors. Streaming. ZIO has powerful, efficient, and concurrent streaming that works with any source of data, whether structured or unstructured, and never leak resources. Troubleshooting. ZIO capture all errors including parallel and finalization errors with detailed execution traces and suspension details that troublemaker shooting applications easy. Testability. With dependency inference, ZIO makes it easy to code to inference and ships with the testable clock, consoles, and other core system modules. Let's move forward with data types. So here are 5 data types of ZIO, which are none other than the type aliases of ZIO data type itself. There are namely UIO, URIO, task, RIO, and IO. All of these data types are derived from the ZIO data type. So ZIO is a value that might fail or succeed. It requires 3 parameters: R, E, and A. So R stands for the environment type, representing the dependency the effect need to execute. The two fundamental operations of working with the environment are accessing the environment, example, accessing the database to do something with it, and providing the environment, or providing a database service to an effect that needs one. So it doesn't need anything else. Type E. So E stands for exception type. When an effect fail, it will be needing a type. The benefit of error type is that we know how this function can fail just from its signature. We don't know anything about the implementation, but just by looking at the type signature, we know that it can fail. This is very powerful because we know exactly what kind of error we potentially have to deal with, and we never have to resort to defensive programming to handle unknown errors. So the next type, which is A, which is the success type. When an effect succeed, it will require a type, which can be any of integer, string, double, long, boolean, etc. So let's move forward with its individual types. Coming on UIO. So UIO is nothing but a type of ZIO, which uh, an effect that does not require any environment, and it cannot fail, and it will only succeed with type A, that is UIO. So you can see over here, instead of ZIO any nothing int, we can use UIO of int because it it does not require any uh, environment, and it will not gonna fail. So instead of this, we can use UIO of integer, URIO. So an effect that requires an environment of type R, but it cannot fail and may succeed with type A. So instead of ZIO console nothing integer, we can directly use URIO of console of int because it does require environment and a success type. So instead of this, we can directly use the URIO type. Moving forward, task. So an effect that does not require any environment, it may fail with a throwable or may succeed with a type A. So instead of ZIO of any throwable int, we can directly use task of integer. It does not even require throwable because it is obvious that if we are using task, it will need a throwable error type. Moving forward, RIO, an effect that requires an environment of type R. It may fail with a throwable or may succeed with a type A. So it will be needing the environment type and the succeed type, and it will be needing throwable error type. So instead of ZIO console throwable integer, we can directly use RIO of console comma integer. So moving forward with the IO type, an effect that does not require any environment, it may fail with a type E or it may succeed.
Is the screen got stuck only for me or for other as well?
Yeah, hi Kuldeepak. Actually, I thought there's some network discrepancy from Pallav's side, so he'll be joining in 5. Just wait for
Yeah, no
five
problem.
minutes.
Okay.
Okay.
Hello, am I audible?
Yes, Pallav, you're audible.
Yes, Pallavi, you are.
I believe there was some network issue, so I got disconnected from the call. Okay, so let me just share my screen again. Is it visible?
it is.
Yes.
Okay. Okay. So where did I left?
Yes, you were explaining the IO part.
Oh,
IO data.
all right. All right. So let me just explain it again. So an effect that does not require any environment, it may fail with a type E, which is an exception, or may succeed with a type A. So we can use directly IO type, which contains the throwable, which is the exception part, and the success value of type integer or anything which we want. So instead of ZIO of any throwable integer, we can directly use IO throwable of integer. So these are nothing except the type aliases of ZIO type. So in the coming part, coming demo part, we will see how the type aliasing has been done in ZIO. So moving forward, exception handling. So what is an exception? An exception is an unwanted or unexpected event which occurs during the execution of the program, that is, at runtime. These events change the flow of control of the program in execution. These are the situations that are not too dangerous and can be handled by the program itself. So, in this session, we will discuss these five types of error handling ways, which is either, catch all, catch some, or else, and retry. So let's move forward. Either. So ZIO provides a method called either on effect that produces an effect of type ZIO, R, nothing, and either of type E and A. So E is the exception and A is the success type. As evident from the type resulting, the effect succeeds with an either value. If effects fail, the result is in the form of the left, and if the effect succeed, the result is in the form of right. We will see the demo of all the types in the later part. Moving forward, catch all. So while either model error into left and right and can return a default value, there may be requirement to catch and recover from all types of error and return an effect with a different error type. This can be achieved by catch-all method. It is a callback that can be create and return a new ZIO effect with a different type. Moving forward, catch-sum. ZIO provide a method called catch-sum if we want to catch and recover from only one some type of recoverable error and effectively attempt recovery. Unlike catch-all, catch-sum cannot reduce or eliminate the error type, although it can widen the error type to a broader class of the error. It is used for catching a specific type of error, not all type of error. Moving forward, or else. The or else operator is kind of a fallback operator as it returns an effect that will try the effect on the left hand side, and if it fails it will fall back to the effect on the right hand side. Moving forward, retry. This method is used to give some try before handling the exception. For example, in many cases, the program might take a few milliseconds to execute that piece of code, which might fail in the first attempt, but in the another attempt, it might lead to success. However, if it still fails, then we can handle it with any other method. Another example can be of your application that makes an API call in case if it fails. You may want to retry before entering to the error handling. So retry and enables us to recall the effect to a specific number of times if it fails. Moving forward with the demo part. So let me just switch to the IDE. Is my ID visible?
Yes, it is.
All right. So in the session, I was talking about type aliases. So this is the basic example of type aliasing. Here I have alias is the name for integer. I want to use number instead of integer. So I have type alias this as a number. So instead of integer, I will be using number. Instead of string, I can use sentence or anything you want. Instead of long, I'm using big number. Instead of double, I'm using fractional number. So I have type alias all these data types with my personal data types. So here you can see I have initialized variable a and uh, gives it the value 15. So this is the integer variable and an integer value. But when I generate its type, you can see it's a number because I have type alias it over here. So it will be using my type. So let me show over here. So as you can see, all the types which it is using is of my type. And let me just run out of that. So it is giving me the expected output. So this is the type aliasing. So let's move forward on the ZIO type and see how they have type alias its types. So as I told earlier, so the type these are the type aliasing they have done. So you can see instead of ZIO, any E of A, E and A, that means any environment can be there. There should be any exception or success value. You can see the IO type. So it will succeed with of type A and may fail with of type E. But there is no requirement of environment. As you can see of type task, there should be this is the type alias uh, for task. As you can see over here, this is for Rio, this is for UIO, this is for URIO. So these all are the type alias, but you can see everything over here is of type ZIO only. We have just type alias it, nothing else. So this is all the data types which we will be using in the ZIO. So coming on the exception handling part. So let me start with the either. As you can see, I have created an effect which uh, which is the either, and I am intentionally failing it to see how it will be handled. So I use zio.fail if I want to if I want this effect to succeed. So instead of fail, I'll use succeed. But here I intentionally want to fail it. So and the error message I have given it to, I am failing you. So I used dot either, and then I mapped it with case left and case right. So in the case left, here you can see I am failing it intentionally, so it will automatically goes to the case left. Because if it will succeed, let me show you this. It will succeed, it will go to case right. And see, it has succeeded, and now it is showing the info part, but over here. But when I change it to fail, you can see this is the error part. So here I am failing it intentionally, and it will go to the uh, left case, which is and with this exception. So let me just run it. So it shows, oops, it failed with an exception. I am failing because this is the exception I've passed, which is carry forward with from here. So that is how either works. If it fails, it will go to case left and return the expected result. Over here, this is the run method. It is an abstract method. When we extend ZIO.app, we have to define it over here. So I have done chaining using the for comprehension. So that is how I am printing the output into the console with this. So there are no side effects because I'm not printing anything directly to the console. So this is also an effect. Let's move forward with catch on. So this is an effect uh, which we will be testing. So this effect will gonna fail because I've used co.fail, and here we are catching it with any type, all the types of exception it will catch, and it will return succeed. It will return a new effect which will succeed and print this output into the console. Let's just run. So as you can see, the output is here. So it will catch all the types of exceptions which can occur. And here I'm also using the same thing for comprehension for the chaining and printing the output to the console. Go forward with catsum. So over here, catsum, I am trying to access this file which is not present over here. You can see, and I have a backup file. You can see over here. Hi, this is a backup file. So I'm trying to access this file which is not present. So it will throw an error, and I will catch it with a type file not found exception, and after that I'll use this backup file and try to get the lines, the data inside this file, and print it into the console. So I'll let me just run it, then I'll explain. So you can see the output of the file, the content of the file which was there, it's in the console. So what I did is I tried to access this file which is not present over here. After that, I use catsum, and in catsum, I am using specific type of exception, which is file not found exception, because this file is not present over here in the project. So if this if this error is same with this type, it will try to access this file and print all